So in this session, we will mainly discuss about the organizational intelligence. What's the definition and what are the differences between the organizational intelligence and business intelligence and operational intelligence? What are the factors that affect the organizational intelligence and many other related topics? And we will next see what is data profiling and different aspects of data profiling. And finally, we will see what is data cleansing and what are the features of a quality data and how to perform the data cleansing steps. So we were discussing about the organizational intelligence. Organizational intelligence is the capability of an organization to comprehend and conclude the knowledge relevant to its business purpose. In other words, it is the intellectual capacity of the entire organization. With relevant organizational intelligence comes great potential value for the companies, and therefore organizations find, study where their strengths and weakness lie in responding to change and complexity. Organizational intelligence embraces both knowledge management and organizational learning, as it is the application of knowledge management concepts to a business environment. Additionally, including learning mechanisms, comprehension models, and business value network models, such as the balanced scorecard concept. Organizational intelligence consists of the ability to make sense of complex situations and act effectively to interpret and act upon relevant events and signals in the environment. It also includes the ability to develop, share, and use knowledge relevant to its business purpose, as well as the ability to reflect and learn from experience. While organizations in the past have been viewed as complete compilations of tasks, products, employees, profit centers, and process, today they are seen as intelligent systems that are designed to manage knowledge. Scholars have shown that organizations engage in learning process using tacit forms of intuitive knowledge, hard data stored in computer networks, and information gleaned from the environment, all of which are used to make sensible decisions. Because this complex process involves large number of people interacting with diverse information systems. Organizational intelligence is more than the aggregate intelligence of organizational members. It is the intelligence of organization itself as a larger system. So what's the difference between organizational intelligence and operational intelligence? Organizational intelligence and operational intelligence are usually seen as subsets of business analytics. They are types of know-how that have the goal of improving business performance across the enterprise. Operational intelligence is often linked with real-time business intelligence, since both deliver visibility and insight into business operations. Operational intelligence is different from business intelligence, primarily in activity-centric things, whereas business intelligence is data-centric and relies on a database. It is after the fact. and report-based approach to identify patterns in the data. So operational intelligence works in real time and transforms unstructured data streams from log files, sensors, networks, and service data into real-time actionable intelligence. Operational intelligence is activity focused and business intelligence is data focused. Organizational intelligence helps companies understand the relationship that drive their business by identifying communities as well as employee workflow and collaborative communications patterns across geographies, divisions, and internal and external organizations. Then we have information process. So there are many aspects that organizations must consider in the 3 steps that they take to gain information. Without these considerations, organizations may experience strategic challenges. The first one is acquiring information. So first is organizations must acquire applicable information to make beneficial predictions. An organization must ask what they already know and what they need to know. They must also know the time frame in which the information is needed and where and to find it. To make the best judgments, they must also evaluate the value of the information. Seemingly valuable information that costs more to find than gain from can hurt the company. If judged valuable, the organization must find the most effective means of acquiring it. So in the acquiring information step, organizations must acquire applicable information to make beneficial predictions. An organization must find the information. They must know the time frames in which the information is needed and where to find it and all. The second step is how to process information. So once you acquire the right information, you must know how to properly process it. You need to know how the information can make, how the people can make new information more retrievable, and how they can make sure that the information gets disseminated to the right people. The organization must figure out how to secure it and how long they need to preserve it. The third step is making use of information. So this is a third step in information process, which includes the utilization of information. An organization should ask themselves if they are looking at the right information, and if so, if they are placing them in the right context. They must consider the possible environment changes, alter the informational value, and determine all the relevant connections and patterns, not forgetting to know if they are including the right people in the decision-making process, and if there are any technology that can improve the decision-making. So next is how the organization will ignore the facts. So that is known as ignorance from the organizations. So there are few dimensions of problems that many organizations face when dealing with information. So this we call it as organizational ignorance. So the first dimension is complexity. Then ambiguity. Then uncertainty. Then equivocality. So equivocality means an organization can be having competing frameworks for interpreting a job. Equivocality refers to multiple interpretations of the field. Each interpretation is unambiguous but differ from each other, and they may be mutually exclusive or in conflict. Equivocality results not only because everyone's experiences and values are unique, but also from unreliable or conflicting preferences and goals, different interests, or vague roles and responsibilities. Then ambiguity. An organization may not have a conceptual framework for interpreting the information. If uncertainty represents not having answers, and complexity represents difficulty in finding them, ambiguity represents not being able to formulate the right questions. Ambiguity cannot be resolved by increasing the amount of information. An organization must be able to interpret and explain the information in collective agreement. Hypotheses should be continuously made and discussed, and key communication activities such as face-to-face conversations must be made. Resolving ambiguity in the earlier stages than competitors gives organizations much advantage because it helps organizations to make more appropriate and strategic decisions and have better awareness. So what is uncertainty? An organization may be uncertain when it does not possess enough or the right information. To amplify a company may be uncertain in a competitive landscape because it does not have enough information to see how the competitors will act. This does not imply that the context of the situation is complex or unclear. Uncertainty can even exist when the range of possibilities is small and simple. There are different degrees of uncertainty. First of all, an organization can be completely determined, have some probabilities estimated with less unknown probabilities or undefined. However, with the lack of clarity, uncertainty assumes that the context of the problem is clear and well understood. Then finally, what is complexity? An organization may be processing more information than they can manage. Complexity does not always correlate with vagueness or unpredictability. Rather, it occurs when there are too much or when the scope is too large to process. Organizations with complexity problems have interrelated variables, solutions, and methods. Managing these problems is dependent on the individuals and the organizations. For instance, uninformed and novices must deal with each elements and relationships one by one. But experts can perceive the situation better and find familiar patterns more easily. Organizations facing complexity must have the capacity to locate, map, collect, share, exploit on what the organizations need to know. So uncertainty. An organization may be uncertain when it does not possess enough of the right information. To exemplify, a company may be uncertain in a competitive landscape, but it does not have enough information to see how the competitors will act. This does not imply that the context of the situation is complex or unclear. Uncertainty can even exist when the range of possibilities is small and simple. There are different degrees of uncertainty. First of all, an organization can be completely determined, have some probabilities estimated with lesser confidence, unknown probabilities, or undefined. But however, even with the lack of clarity, uncertainty assumes that the context of the problem is clear and well understood. Then complexity. An organization may be processing more information than they can manage. Complexity does not always correlate with vagueness or unpredictability. Rather, it occurs when there are too much or when the scope is too large to process. Organizations with complexity problems have interrelated variables, solutions, and methods. Managing these problems is dependent of the individuals and the organizations. For instance, uninformed and novices must deal with each elements and relationships one by one, but experts can perceive the situation better and find familiar patterns more easily. Organizations facing complexity must have the capacity to locate, map, collect, share, exploit on what the organizations need to know. Then ambiguity. An organization may not have a conceptual framework for interpreting the information. If uncertainty represents not having answers and complexity represents difficulty in finding them, then ambiguity represents not being able to formulate the right questions. Ambiguity cannot be resolved by increasing the amount of information. An organization must be able to interpret and explain the information in collective agreement. Hypotheses should be continuously made and discussed, and key communication activities must be made. Resolving ambiguity in the earlier stages than competitors gives organizations much advantage because it helps organizations to make more appropriate and strategic decisions and have better awareness. Then equivocality. An organization may be having competing frameworks for interpreting a job. Equivocality refers to multiple interpretations of the field. Each interpretation is unambiguous but differ from each other. And they may be mutually exclusive or in conflict. Equivocality results not only because everyone's experiences and values are unique, but also from unreliable or conflicting preferences and goals, different interests or vague roles and responsibilities. Next is data profiling. Data profiling is the process of examining the data available in an existing information data source and collecting statistics or small but informative summaries about the data. So the statistics that are collected can serve different purpose. It can improve the ability to search the data by tagging it with keywords, descriptions, or assigning it to a category. We can assess whether known metadata accurately describes the actual values in the source database. We can have an enterprise. We can have an enterprise view of all data. We can use them in master data management where key data is needed, or data governance for improving the data quality. It can give metrics on data quality, including whether the data conforms to particular standards or patterns. It can assess whether known metadata accurately describes the actual values in the source data source. It can be used to find out whether existing data can be easily used for other purposes. It improves the ability to search the data by tagging it with keywords, description, or assigning it to a category. It can give metrics on the data quality. It can assess the risk involved in integrating data for new applications, including the challenges of joins. So data profiling refers to the analysis of candidate data sources for the data warehouse in order to clarify the structure, content, relationships, and derivation rules of the data. Profiling helps not only to understand anomalies and assess data quality, but also to discover register and assess enterprise metadata. Thus, the purpose of data profiling is both to validate metadata when it is available and to discover metadata when it is not. The result of the analysis is used both strategically to determine the suitability of the candidate source systems and give the basis for an early decision, and tactically to identify problems for later solution design, and to level sponsors' expectations. Profiling helps not only to understand anomalies and assess data quality, but also to discover, register, and assess enterprise metadata. So data profiling utilizes different kinds of descriptive statistics such as minimum, maximum, mean, mode, percentile, standard deviation, frequency, and variation, as well as other aggregates such as count and sum. Additional metadata information obtained could be the data type, length, discrete values, uniqueness, occurrence of null values, typical string patterns, and abstract type recognition. The metadata can then be used to discover problems such as illegal values, spelling mistakes, missing values, varying value representation, and duplicates. Different analyses are performed for different structural levels, like single columns could be profiled individually to get an understanding of frequency distribution of different values. Type and use of each column. Embedded value dependencies can be exposed in a cross-columns analysis. Finally, overlapping value sets, possibly representing foreign key relationships between entities, and can be explained or explored in an inter-table analysis. Normally, purpose-built tools are used for data profiling to ease the process. The computation complexity increases when going from single column to single table to cross-table structural profiling. Therefore, performance is an evaluation criteria for profiling tools. So the benefits of data profiling are to improve data quality, shorten the implementation cycle of major projects, and improve understanding of data for users. Discovering business knowledge embedded in data itself is one of the significant benefits. derived from data profiling. Data profiling is one of the most effective technologies for improving the data accuracy in corporate databases. Although data profiling is effective and useful for each sector of our daily life, it can be challenging not to slip into analysis paralysis. So next we will see data cleaning. Data cleaning detects and corrects corrupt or inaccurate records from a record set, table, or database, and refers to identifying incomplete, incorrect, inaccurate, or irrelevant parts of the data, and then replacing, modifying, or deleting the dirty or coarse data. Data cleansing may be performed interactively with data wrangling tools or batch processing through scripting. Data cleansing may be performed interactively with data wrangling tools or as batch processing through scripting. After data cleaning, a data set should be consistent with other similar data sets in the system. The inconsistencies detected or removed may have been originally caused by user entry errors, by corruption in transmission or storage, or by different data dictionary definitions of similar entities in different stores. Data cleansing differs from data validation because validation almost invariably means data is rejected from the system at entry and is performed at the time of entry rather than on batches of data. The actual process of data cleansing may involve removing typographical errors or validating and correcting values against a known list of entities. The validation may be strict or fuzzy. Some data cleansing solutions will clean data by cross-checking with validated dataset. A common data cleansing practice is data enhancement, where data is made more complete by adding related information. For example, appending address with any phone numbers related to that address. Data cleansing may also involve activities like harmonization of data, standardization of data. For example, harmonization of codes to actual words. Standardization of data is a mean of changing a reference data set to a new standard. For example, use of standard codes. So incorrect or inconsistent data can lead to false conclusions and misdirected investments on both public and private scales. For instance, the government may want to analyze population census figures to decide which regions require further spending and investment on infrastructure and services. In this case, it will be important to have access to reliable data to avoid erroneous fiscal decisions. In the business world, incorrect data can be costly. Many companies use customer information databases that record data like contact information, address, and preferences. For instance, if the address is inconsistent, the company will suffer the cost of resending mail or even losing the customers. The profession of forensic accounting and fraud investigating uses data cleansing in preparing its data and is typically done before data is sent to a data warehouse for further investigation. There are packages available so you can cleanse, wash, address data while you enter it into your system. This is normally done via an API and will prompt staff as they type the address. High quality data needs to pass a set of quality criteria. So let's see what are those criteria. So validity. Set membership constraints. Data type constraints. Range constraints. Unique constraints. Mandatory constraints. Foreign key constraints. Regular expression patterns, cross-feed validation. Accuracy. Completeness, consistency, and uniformity. The degree to which a set data measures are specified using the same units of measures in all the systems. This is known as uniformity. In data sets pulled from different locales, weight may be recorded either in pounds or kilos, or must be converted to a single measure using an arithmetic transformation. Then consistency, the degree to which a set of measures are equivalent in across systems. Inconsistency occurs when two data items in the data set contradict each other. Example, a customer is recorded in two different systems as having two different current address, and only one of them can be correct. Fixing inconsistency is not always possible. It requires a variety of strategies. For example, deciding which data was recorded more recently, which data source is likely to be most reliable, or simply trying to find the truth by testing both data items. Then completeness. The degree to which all required measures are known. Incompleteness is almost impossible to fix with data cleansing methodology. One cannot infer facts that were not captured when the data in question was initially recorded. In some context, interview data, it may be possible to fix incompleteness by going back to the original source of data. For example, re-interviewing the subject, but even this does not guarantee success because of problem of recall. For example, in an interview to gather data on food consumption, no one is likely to remember exactly what one ate 6 months ago. In the case of systems that insist certain columns should not be empty, one may work around the problem by designating a value that indicates unknown or missing, but supplying of default values does not imply that the data has been made complete. Then accuracy, the degree of conformity of a measure to a standard or the true value. Accuracy is difficult to achieve through data cleansing because it requires accessing an external source of data that contains the true value. Such gold standard data is often unavailable. Accuracy has been achieved in some cleansing contexts. For example, customer contact data by using external databases that match up zip codes to geographical locations and also help verify that street address within these zip codes actually exist. Then cross-field validation. Certain conditions that utilize multiple fields must hold. For example, in laboratory medicine, the sum of the components of the differential white blood cell count must be equal to 100. In a hospital database, a patient's date of discharge from hospital cannot be earlier than date of admission. Regular expression patterns. Occasionally, text fields will have to be validated this way. For example, phone numbers must be required to have a pattern. Then foreign key constraints. This is a more general case of set membership. The set of values in a domain is defined in a column of another table that contains unique values. For example, in a US taxpayer database, the state column is required to belong to one of the US defined states or territories. The set of permissible states is recorded in a separate states table. The term foreign key is borrowed from relational database terminology. Mandatory constraints. Certain columns cannot be empty. Then unique constraints. A field or a combination of fields must be unique across a data set. For example, no two persons can have the same social security number. Then range constraints. Typically, numbers or dates should fall within a certain range. They have a maximum or minimum permissible values. Then data type constraints. Values in a particular column must be of a particular data type. For example, Boolean, numeric, date, etc. Then set membership constraints. The values for a certain column come from a set of discrete values or codes. For example, a person's gender may be male, female, or unknown, that is not recorded. Then validity, the degree to which the measures conform to the defined business rules or constraints. When modern database technology is used to design data capture systems, validity is fairly easy to ensure. Invalid to ensure invalid data arises mainly in legacy contexts or where inappropriate data capture technology was used. So while performing data cleansing, the following steps should be followed. First is data auditing. The data should be audited with the use of statistical and database methods to detect anomalies and contradictions. This eventually gives an indication of the characteristics of the anomalies and their locations. Several commercial software packages will let you specify constraints of various kinds and then generate code that checks the data for violation of these constraints. This process is referred as workflow specification and workflow execution. For users who lack access to high-end cleansing software, microcomputer database packages such as Microsoft Access will let you perform such checks on a constraint by constraint basis, interactively with little or no programming required in many cases. Then workflow specification. The detection and removal of anomalies is performed by a sequence of operations on the data, known as the workflow. It is specified after the process of auditing the data and is crucial in achieving the end product of high quality data. In order to achieve a proper workflow, the causes of the anomalies and errors in the data have to be closely considered. Then workflow execution. In this phase, the workflow is executed after its specification is complete and its correctness is verified. The implementation of the workflow should be efficient, even on large sets of data, which inevitably poses a trade-off because the execution of data cleaning operation can be computationally expensive. Then post-processing and controlling. After executing the cleansing workflow, the results are inspected to verify correctness. Data that could not be corrected during execution of the workflow is manually corrected, if possible. The result is a new cycle in the data cleansing process where the data is audited again to allow the specification of an additional workflow to further cleanse the data by automatic processing. Good quality source has to do with data quality culture and must be initiated at the top of the organization. It is not just a matter of implementing strong validation checks on input screens, because almost no matter how strong these checks are, they can often circumvented by the users. So the essential job for data cleaning is to find a suitable balance between fixing dirty data and maintaining the data as close as possible to the original data from the source production system. This is a challenge for the extract, transform, and load architecture. The system should offer an architecture that can cleanse data, record quality events, and measure control quality of data in the data warehouse. A good start is to perform a thorough data profiling analysis that will help define the required complexity of the data cleansing system and also give an idea of the current data quality in the source system. Part of the data cleansing system is a set of diagnostic filters known as quality screens. Implement a test in the data flow that if it fails, records an error in the error event schema. So there are three categories of quality screens. Column screens, structure screens, business rule screens. Column screens, they test the individual column. Like out of range values, null values, non-numeric values. The structure screen are used to test for the integrity of different relationships between columns in the same or different tables. They are also used for testing that a group of columns is valid according to some structural definition it should stick to. Then business rule screens is the most complex of the three sets. They test to see if the data follows specific business rules. For example, if a customer is marked as a certain type of customer, the business rules that define this kind of customer should be adhered. When a quality screen records an error, it can either stop the data flow process, send the faulty data somewhere than the target system, or it can tag the data. The latter option is considered the best solution because the first option requires that someone has to manually deal with the issue each time it occurs, and the second implies that data is missing from the target system and it is often unclear what should happen to the data.